By the end of this lesson, you'll be able to explain what is meant by a physical quantity in physics. You'll be able to distinguish between base or fundamental quantities and derived quantities and their units. You'll be able to state the 7 fundamental quantities recognized and used in physics. You'll be able to explain the need for units when dealing with physical quantities, and also use multiples and sub-multiples of physics. Measurement is something we use every day to find the value or size of things. A well-defined and agreed upon reference is used as a standard called a unit. Measurements are always reported with a number or a value and a name for the unit. For example, you can have 8 seconds, you can have 9 kilograms, you can have 40 ampere. We describe the property using a wide variety of units depending on what it is we are measuring, but the result always begins with a number, usually followed by the unit. So then, what shall we say measurement is? Measurement is a process of comparing a physical property to a well-defined and agreed upon reference. And so, before we can say kilogram, it means that it has been agreed conventionally that anybody who takes a particular mass of a substance should measure it using a certain reference called the kilogram. If we say second, it means that people all over the world have agreed that let us use the reference second. SI unit. So an SI unit is a unit of measurement that is accepted and understood by people all over the world. In SI units, the standard unit of mass is a kilogram, that for length is the meter, and that for time is the second. This system used to be called the MKS, the meter kilogram second system. Now there are units which are non-SI, but they have been agreed upon that we can use them. Sometimes they are derived, sometimes also they are not derived. So some of them are the centimeter, the cubic centimeter, the gram, the kilometer, degrees Celsius. These are not SI units, but they can also be used for measurement. They have conversion modes to SI units. Now, what is a physical quantity? A physical quantity is any phenomenon that can be measured, defined, and has a unit. Or it is any measurable attribute of any form of matter that can be defined and has a unit. Now, physical quantities can be grouped in 2 ways. Either they are fundamental quantities or derived quantities, or you can group them as either scalar quantities or vector quantities. Every physical quantity that exists falls under one of these based on the categorization you are using. Fundamental quantity is also known as a base quantity, and it is a physical quantity which does not depend on any other physical quantity for definition. And so it means that you are having mass, you are having temperature. These quantities, they don't depend on any other quantity for definition. What I measure straight away from the measuring instrument is what I'm using. Base quantities or fundamental quantities have certain fundamental properties in that they are not related to each other, they are not derivations of other quantities, and they can produce or derive other quantities. Now, there are 7 fundamental quantities in use. The first one is the mass, which has a unit of kilogram, length, which has a unit of the meter, time, which has a unit of the second, temperature, which has a unit of the Kelvin, electric current, which has a unit of the ampere, luminous intensity, which has a unit of candela, amount of substance, which has a unit of mole. The mass of a body is a measure of the quantity of matter contained in the body. Like we saw in our table, the SI unit of mass is the kilogram. Some measuring instruments used to measure mass are the lever balance, the beam balance, the electronic balance, the top pump balance, and the chemical balance. The weight of a body is the force the body exerts downwards due to the pull of gravity. The SI unit of weight is the Newton. The weight is measured using the spring balance, and so weight and mass are not the same. Time is the interval between two events. The SI unit of time is the second. Time is measured by using either a stopwatch or a stop clock or a digital watch. Now, length is the measurement of the distance or how far 2 points are in space. Its SI unit is the meter. Based on the length, how large the length is and the type of measuring instrument you use. Some examples of measuring instruments you use to measure length are the vernier caliper, the micrometer screw gauge, the meter rule, the tape measure, surveyor's tape, etc. Derived quantity. A derived quantity is a physical quantity which is obtained by combining two or more fundamental quantities through multiplication, division, or both. The units of derived quantities are called derived units, and they are obtained by combining two or more fundamental units through multiplication, division, or both. Now let's look at some examples. Area is a derived quantity because it is derived from the base quantities length times length. Volume is another derived quantity because it is obtained from the fundamental quantities length times length times length. Density is also another derived quantity. Remember, the formula for measuring density is density equal to mass divided by volume. Earlier on, we said that volume is length times length times length. So you can see that we have expressed the formula for density in terms of fundamental quantities. All other quantities apart from the 7 base quantities are derived from the 7 base quantities. So this is a table of derived quantities which have no special unit names. So area is meter squared, volume is cubic meter, density is kilogram per cubic meter, momentum is kilogram meter per second, viscosity is Newton second per meter squared, velocity is meter per second, acceleration is meter per second squared, pressure is Newton per meter squared. Now there are those which have special unit names. Force is Newton. Newton is representing kilogram meter per second squared. You have power, which is watts. You have energy, which is joule, pressure, Pascal, electric resistance, ohm, frequency, hertz, electromotive force, volt. A standard form, it expresses a number between 1 and 9.99999. That is multiplied by a power of 10. It is also referred to as scientific notation. A number written in the standard form has only one digit before the decimal point. Examples are 1243 standard form is 1.243 times 10 to the power 3. You will see that the number before the decimal point lies between 1 and 9.9999. So the rest you express as a power of 3. 12.43, it means that we have to move the decimal point to the left once. So because we moved it once, this is going to be to the 10 is going to be to the power 1. So 1.243 times 10 to the power 1. 0.1243, we can see that the 0 does not lie between 1 and 9.99999. So we have to move the decimal place to make it possible. So what we shall do is to move the decimal place to the right once. So you can see that because we moved it to the right, the 10 is to the power negative 1. So 1.243 times 10 to the power negative 1. Express the following numbers in standard form. 0.00234. We have to move the decimal place 1, 2, 3 times in order to make the first number before the decimal point come between 1 and 9.9999. So you have 2.34. Because we moved it 3 times to the right, you see that this times 10 to the power minus 3. Here 3833.33. See that 3833 is bigger than a number between 1 to 9.999. So we have to move the decimal point to the left 1, 2, 3 times. Because we moved it to the left, 10 is to the power 3. So we have 3.83333. The third one, 0.000000002. We have to move the decimal point to your right 8 times. So 1, 2, 3, 4, 5, 6, 7, 8. So you have 2 times 10 to the power minus 8. Here we have to move the decimal point to the left 5 times. So we have 1.2345678 times 10 to the power 5. Thank you. Remember to subscribe to our YouTube channel, Mastermind e-learning, so that you will be updated on new lectures we post online. Thank you.